Saul, it's great to have you here. It's really exciting to talk about the work you've been doing about climate change and its impacts. And I hope we'll have a good exploration of those really fascinating topics. You just completed a report that ended up being part of a report that got a lot of press called Risky Business. Can you explain what you did and what the Risky Business report is about?
Yeah, so I was a member of a team, a research team that worked on a report called the American Climate Prospectus. And that was an objective assessment of the economic risks posed by climate change to the U.S. economy. And then the details of that report was distilled down to a shorter report that was sort of more amenable to public consumption. That was the Risky Business report that was publicized and discussed by many leading thinkers, a bipartisan committee of risk committee members across various sectors and across the country. And
who sponsored this work?
The report was sponsored by a bipartisan group, Hank Paulson, Tom Steyer, and Michael Bloomberg.
Hank Paulson was Secretary of the Treasury. Tom Steyer is a hedge fund manager. And Michael Bloomberg, of course, was the mayor of New York City.
Yes.
And also a person of some wealth. So why in the world were they interested in this topic? What was the point?
Well, all three of them are professional risk managers in financial institutions. And so they're very used to thinking about risk and sort of the probability of different types of economic outcomes. And they realized that climate change should be thought of in that context. And so what they wanted was a risk assessment of climate change the way one would conduct a risk assessment if the country were a business. Mm-hmm. So that's what we tried to produce.
So here, the goal is not so much to convince people one way or the other about climate change. It's to say, if you have entertain any thoughts that possibly climate change is occurring, you might want to think about what the risks of that might be.
Absolutely. The goal here was not to convince anyone. It was just to simply outline if we do A, B might occur in the economy. And we actually looked at a variety of different climate scenarios to think about if the climate doesn't change very much, or if it changes a moderate amount, or if it changes quite a bit. So we weren't taking a stand on exactly what would happen, or what even the economic costs of fighting climate change are. All we were doing was looking at how, if the climate changes, how that will translate into economic outcomes and human experience on the ground.
So as a financier, for example, I'm about to go invest in Florida real estate. Why would your report help me? How could it help me?
So what we did was we tried to think about different sectors and how they might be affected in the future if we go down different sort of climate paths. And so in Florida, for example, one thing that matters is the mortality rate, or the productivity of your laborers, or the risk of homes on the coast to getting struck by a hurricane. And so we calculated all of those things in a sort of very probabilistic framework to think about these as economic risks, things that may happen or may not happen, and we tried to understand how likely each outcome was.
So for example, I might decide that I'm not going to buy coastal property in Florida because it's possible that that would be underwater by 2070 or something like that.
Absolutely. And we worked very hard to try and put concrete numbers on the probability of different depths of water, for example, in that particular case.
So how does this differ from what the Intergovernmental Climate Change panel did? What were they trying to do? This is the one that won the Nobel Prize for talking about climate change. How did you go beyond what they did?
So the IPCC, the organization that you talk about, is an assessment process that tries to synthesize the state of scientific research every few years. And that's basically a very large review process to say what can we all agree on. That has been focused primarily on the physics of the problem and recognizing where there are human impacts. But they have never, anywhere in any of the previous reports, tried to quantify these sort of economic risks in dollar terms or at this resolution. So we made a variety of different types of methodological innovations that allow us to do this. But also the goals of the two organizations are very different. And so we were trying to do a real risk assessment rather than just a scientific assessment.
Right. So the panel has really been trying to understand whether there's climate change, and to some extent, in just sort of a very gross way, what the effects will be around the world. But you actually tried to get down all the way to the county level and even below that level. So one of the innovations, as I understand it, is that you actually tried to get very fine spatial detail on what was going on. So tell me about how you do that. You start with climate change models. How do you get down to a piece of property in Florida?
Yeah, so that is one of the innovations, is trying to bring these very abstract global scale phenomena down to the level that we all live at. And so there was a fairly sophisticated modeling process where we look at a variety of climate models. There's actually numerous teams around the world that create climate models. These are large computerized models similar to a weather model, but they run forward for an entire century. And we looked across all those different climate models, and we say, each model might be right. Then we take those models, we take the information about what the US looks like in each model, and we try to compute in each model what each county is experiencing.
So there's 3,000 counties in the United States, so you're actually trying to get down to a pretty small geographic area when you're doing that.
And it's a very computationally intensive process. So we're looking across basically 40 different possible scenarios of what the future United States looks like. And then within each one of those, we have about 10 scenarios for what the weather patterns, random weather patterns might look like. So we're talking about 400 different simulations of each different possible future. Now we actually looked at 3 different possible futures, sort of not much warming, moderate warming, and high warming. So that ends up being a very computationally intensive exercise.
It sounds like an enormous amount of data.
Yeah, so we unexpectedly filled up our 10 terabyte server during the calculations. And so at the last minute, we had to go out and plug in a couple more hard drives just to record all the data that we were producing.
So could this study have been done 10 years ago?
No, this is one of the things that has been made possible by modern computing. And this study couldn't have been done 10 years ago in part because the sort of econometric studies.
Econometric?
So statistical studies that have been used to try and measure the effect of the climate on populations or economies. This is the type of work I normally work on, is the detection problem. What is the effect of climate on the economy? Those studies have only been generated in the last 10 years. We've only solved a lot of these statistical problems very recently. And then we were building on those prior studies using this sort of probabilistic approach that's quite intensive. And so those two things combined means that we went much further than what people have done in the past. Things like the Stern report or the DICE model by Bill Nordhaus have been extremely important in informing how we think about this problem in a very abstract sense. But it's been so hard to handle this sort of large volume of complex multidimensional data that we haven't been able to integrate sort of the tangible data on the ground with these very high-level visions until now. And that's what we've been trying to do.
So you actually had to do work where you figured out what the impact was of changes in the climate, and then all the way down to the county level. And then you had to think about, okay, if the climate changes in that way in that county, it's going to have impacts on human activities. And the human activities include what? What kinds of things were you looking at?
So we looked across a variety of sectors. That's exactly right in terms of what we were doing. And we tried to build on prior studies where people have detected the effects on different types of human activities. Now, in reality, the climate probably affects almost everything we do, but we don't have careful numbers for everything. So we only relied on the things that we had a very solid understanding of. So for example, we looked at what is the effect on agriculture. When it becomes hotter, when it rains more or less, agricultural production responds. And so we tried to forecast how that would evolve with time at different locations around the country. We also looked, for example, at the effect of hurricanes on destruction of property along the US coastline. We also looked, for example, at changes in how laborers supply labor. So we actually observed that on very hot days, people who have to be outside for most of the day work less. And I think we all can relate to that. It's quite exhausting to be working outside. And so we used that information to look at changes in labor supply. We also looked at changes in mortality rates. So this is an interesting case because mortality rates are higher both when it becomes very cold as well as when it becomes very hot. People have different types of health problems at different temperatures. And so some places that are already very cold, as they warm up, will actually have lower mortality rates. They'll actually benefit from some warming, whereas places that are already quite hot, a place like Florida, as they become warmer, mortality rates will be expected to rise. And so this is a case where sort of looking at specific locations and how their environment is going to change was really important because nationally the response looks very different. Some places are going to be winners, some people are going to be losers. On average, we're going to be something totally different.
So your report not only talks about physical labor, but cognitive kinds of skills and how they're degraded with increasing heat. Say a little bit about that.
We actually have laboratory studies where people have in the past studied the fact that people perform badly on cognitive tasks at high temperature. However, in this report, we actually didn't include any of that type of modeling because there are no studies from the field. Everything that's been done in the past was in the laboratory, but we sort of think it's important to have ecologically valid studies that occur in sort of realistic environments when making these types of projections. So that's one category where we didn't include that information, and a future assessment should include that if we can get those types of numbers, and that will cause us to update our evaluation of the risk. But there are things like crime that do respond to temperature. And so one important sector that we modeled was how both property and violent crime will change with the climate. And this is actually a very well documented phenomenon. And what's interesting is that property crime is primarily suppressed by cold temperatures. So for example, people are not stealing cars when they're under snow, but when temperatures reach around 50 degrees, we sort of see that property crime kind of reaches a maximum and levels off. Hotter days don't have much more property crime. But violent crime continues to increase with high temperatures, very linearly. And so as you have hotter and hotter days, we observe more and more violent crime of many different types. And we don't exactly know what causes it, but what we think is that it's something psychological about how people really respond to one another. There have been laboratory experiments, again, thinking about this, and we see that people, for example, feel more threatened by other individuals, even though they might be just watching a video of the same sort of simulated attack. And that makes us think there's something deep and psychological that changes when the environment changes, and that's something that we're sort of cautioning people about in this assessment. It's the first time folks have tried to make a kind of projection of these types of social changes in addition to just economic changes.
And although I don't think it's in this report, but other research I know you've done talks about how violence in terms of even civil wars and violence that leads to revolutions increases with temperature.
Absolutely. So that is other work I've done. And in fact, that work was not used here. We weren't modeling the collapse of American civilization or civil wars in the United States. But that is other work we've done. And you know, when we think about poorer countries that face stronger resource constraints, that's something that we are quite concerned about. The US economy will respond to climate change with probably much more resilience than many of these populations that have much fewer resources to sort of at their disposal.
And many of those countries, certainly in the equatorial regions, will have tremendous amounts of increases in temperatures, and therefore it's quite conceivable you would see more violence in that area. And in fact, isn't it the case that the national security agencies, the Defense Department and some of the intelligence agencies, take climate change pretty seriously for that very reason?
Absolutely. They are out front and trying to get Congress and others to really confront this issue and think about it. They're already preparing for climate change. They're very proactive. They know it's an issue. They see the impacts on the ground. And when we talk to them about it, they really want to think about what these implications are for their job in the future.
So you've got a lot of this on the web, the maps that you've produced, which are down to the county level, and that give a colored version of what would happen in the future, where you use red for increased temperatures or problems of various sorts, and green for not such increased temperatures. Right now we're looking at the southeast, so it's Florida and Georgia and all the way over to Louisiana, it looks like.
We see in general sort of warming across most of the United States. Precipitation patterns are much more variable. And you can see that as you move forward in time, towards later and later in the century, the
this
southeast
map
becomes,
actually, you can see it over time. So that's what you just did, is you moved over time, and by the time you're at the end of the current century,
we're seeing that, you know, across the southeast, that summertime temperatures are on average, you know, in the 80s and 90s. And so normally we see some sort of variation. We have some hot days and we have some cool days, but what we expect to see moving forward is that sort of most days look like the very hot days. And so it's like having, instead of just a few of those extreme days, it's like having many, many of them. And then the extreme days in the future will be things that have been sort of previously off the chart.
So, for example, in one graphic you have, you show that New Jersey is going to be like...
Summer times in sort of states like New York and New Jersey and Pennsylvania are going to look in the future the way that summer times in Louisiana and Texas now feel today.
And what's Louisiana and Texas going to look like?
They're gonna look like things we've never seen in this country before. You know, they're gonna look like things that sometimes happen in the tropics, but they will be hotter by many, many degrees in the summer than they have been historically.
And so, just to go through some of the impacts this will have, just to do it really quickly. So, for example, on agriculture, health, jobs, just play out the scenario of what's going to happen in New Jersey or New York or those kinds of states.
Well, so in the states that are already pretty warm, higher temperatures lead to reduction in agricultural yields across a variety of crops, but that depends a little bit on what types of crops are grown in different places and how each one is sensitive to temperature. We're going to see less labor supply, higher demand for energy, which is going to increase energy costs. We're going to see higher sea levels, which are going to inundate some places on the very coastline on average. But the real problem with sea level rise is not just the fact that the water goes up a little bit on average, it's that when you have a big hurricane coming in that causes the sea to go up quite a bit, now that big surge, which is already inundating large pieces of the coast, goes up and becomes even higher. And so adding up to, onto those is going to cause sort of tens of billions of dollars of additional damage per year. We're going to see higher crime rates by a few percentage points on average in most of these places.
And violent crime, more likely
violent
than property.
crime. Violent crime is a larger change than property crime. We're going to see higher mortality rates, which have actually tremendous economic cost. If you think about, what is the effect of someone dying early? There's value to life. We spend a lot of money trying to stay healthy and keeping people alive, but also people are productive during their life. They go to work and they generate value, and if we lose people, we're losing that. So there's a whole variety of different types of economic costs that are associated with these rising temperatures.
So in the Southwest, for example, California all the way over to Arizona and through New Mexico, it includes the Nevada and Utah and Colorado. So let's move this forward. What do we get? So we start out with mostly the area in Arizona and a little bit of the Imperial Valley and the Mojave Desert in California, and then over time.
The Southwest by end of century warms up a great deal. It turns out that actually the coastline of the Pacific is one of those regions that warms much less than the interior. And part of that is because just by being near the ocean and having the winds blow off the water, we get a lot of cooling. And so, sort of, for example, San Francisco and the Bay Area is one of those places that's much less heavily impacted than just surrounding places such as this and the Central Valley.
So then what happens if we go all the way over to Texas? That's which region here? The Great Plains? Is that?
Yeah.
This is really the Great Plains. You're going Texas, Oklahoma, Kansas, up to Wyoming and Montana.
Yeah, and so this is a case where if you look across this region, you see really variable impacts. So you have a northern region that's quite cool to begin with, and a southern region that's quite warm to begin with. And so as you have warming, you actually benefit. The northern regions become sort of more amenable to agriculture, whereas the south is extremely heavily hit. And so, this is a case where you see that there's both winners and losers. Climate change can be thought of almost as like a redistribution of sort of environmental assets.
And I know you didn't do this, but how about Canada? What's going to happen up in Canada?
Canada will warm, and in some cases that could have some benefits. In other cases, it will have large costs. For example, they've been having some ecological disasters associated with warming because, when you have a warmer winter, you don't kill off all these pests. And so some of the pests are devastating many of the forests that they rely on up north. And so there's some benefits and some costs, and the system is sufficiently complicated that it's very hard to predict all of them. Other things, for example, non-mortality related health problems. High temperatures are not good for us for a variety of different reasons, but we have much higher quality data on mortality because the federal government actually collects that type of data. It's actually much harder to understand how extreme temperatures affect just like morbidity, which is just different types of health impacts that don't kill you. And so we don't really know what will happen in that respect. So there, all these different types of impacts that we're not
Forestry?
setting. Forestry is one. Wildfires we know will become more frequent, but we don't have a number for exactly how much. We think that infrastructure will be affected. For example, high temperatures affect electricity transmission lines and whether or not transformers perform well and the rate at which bridges degrade, but we don't have numbers exactly on how they're going to change. So all aspects of our economy are potentially vulnerable to this, and we're just trying to focus on the things that we know. But in the future, as we learn more, we're going to update this report. We've actually built a computerized infrastructure so that it can very easily be updated as we learn more about our own vulnerability. And so this is not going to be the last number. This is just the start of a new way of assessing this problem, putting it in sort of a risk analysis framework with empirical data to back up all the statements that we make.
So let me just bring up one other area, which is water. Because with these kinds of temperatures in Texas and along the south, you would expect that there'd be a lot more evaporation of water from places. I don't know how that affects rainfall. You do have information on that, but I suspect it will change the pattern of where water is available and where it's not available.
Absolutely. Water availability is a major concern. Figuring out how precipitation change, however, is a more challenging problem than temperature for a variety of modeling reasons. So there is substantially more uncertainty in terms when we think about how rainfall patterns are going to change. But in places that become this hot, water scarcity is going to become more pronounced anytime it happens. Like the drought right now, we see in California, we're really struggling just to stay afloat. And we know going forward in this year, it's going to become increasingly costly to deal with just this year's situation. Now imagine you have this year, 10 years in a row, that's going to lead to real water storage problems. That's something we actually also didn't include in this report, but our team is now trying to consider how one would do a proper quantification of that. Water is challenging because water markets in different regions or water distribution networks all have very different nuanced structure with important political players, important infrastructure considerations. And so it's a very nuanced type of system to model and requires sort of attention to detail in a way that we're unable to do here.
So I'd like to push you a little bit in terms of the debate over climate change. I think it's moving to a place where the issues are increasingly between those who say, look, we're not sure what's going to happen with climate change, so what we really should do is focus on adaptation, because trying to mitigate it right now through a carbon tax is going to be so expensive that it's simply not worth it. Does this study provide any insight into that? Would you be able to construct an argument from these data that maybe it's worth some mitigation because we're pretty sure there's going to be some bad effects, and those bad effects are going to be so costly that it's worth the dollar spent now to avoid costs later on?
Yeah, actually we have a whole section where we talk about how this type of analysis can be used to think about the value of mitigation. Mitigation doesn't always have the same value in every sector because a certain amount of warming is already baked into the system. We've already put up enough carbon into the atmosphere that things will be warmer even if we completely stopped burning fossil fuels today. And because of the nature of how human systems respond, that small amount of warming in some cases will have a substantial economic impact. And so even if we stop today, we're still going to bear that cost. Whereas in some cases, we're actually not going to see much cost until we start hitting the really high temperatures. So mortality is a case, for example, where unless we get really hot, the gains, from a national standpoint, the gains from folks in the north who are going to have lower mortality rates are going to pretty much exactly offset the losses from the people in the south who are going to have higher mortality rates. And so it's not until we really hit the end of the century when it gets really hot that we have sort of really large economic costs in that sector. And so if we can just avoid that one case, the worst case scenario, through mitigation, there's potentially large benefits. Whereas in other cases, when we think about crime, it's sort of more of a spectrum, and there's not as much benefit to mitigation as one might, as we have in mortality. So this report really helps us think about the things that we can avoid through mitigation and the other things that we should prepare for through adaptation, because mitigation is really not going to help that much.
But it also makes us think that we better come up with public policies that facilitate adaptation if we're going to use that as one of our strategies.
Absolutely.
So that the entire focus should not be on just mitigation investments like attempts to come up with renewable fuels, although that's great. It would be great if tomorrow we invented a battery that had twice the amount of power per pound of battery as the ones we've got right now. But we also have to think about ways to invest in research that will help adapt to the kinds of changes we're talking about. So
Absolutely.
We know we've got to do that.
Absolutely. And I think a balanced approach from a policy standpoint is probably the right approach. You know, people have a sort of negative gut reaction to these types of policy interventions, and for a long time that has inhibited research and prevented us from understanding what all our options are. So, you know, we sort of, in this analysis, are trying to take a objective stand, looking at both the costs and the benefits of each policy intervention, and to think about sort of what is the best thing for society overall without trying to inject sort of our gut response.
Well, I'm going to push you just even a little more, though. So after doing this kind of research and working with the trio that sponsored it, are you optimistic about the future, that we're going to find ways out of the problems we have, or do you worry that these are just so complex and so risky that we're going to have trouble?
Actually, I found the entire process here extremely refreshing. There's been a very positive response, and in particular, many communities that were generally ignoring this problem or not discussing it because it was not sort of something that they're focused on. For example, the financial communities have responded very positively to the analysis and have said, you know, look, okay, now we understand risk and we manage risk and we can think about how to reduce the probability of these really bad outcomes. And that's been reassuring to me because we're now engaging people who previously weren't engaged in this discussion, and it makes me think that maybe we can solve this problem.
So human beings can adapt and solve problems like this?
I believe so.
Good. Thank you.
Thanks so much for having me.